Hello everyone. Today's topic is exact equivalent circuit of transformer. When we are going to draw the exact equivalent circuit of transformer, first of all we see that there are parameters R1, R2, X1, X2, RC and XM. First of all, let's find out that why we are using these parameters. The parameters R1 and R2. This shows the resistance of the windings that we do on the primary as well as the secondary side of the transformer. So R1 and R2 is nothing but just the value of the internal resistance of the winding. Now let's see about the X1 and X2. See, when we talk about the transformer, then here we talk about the magnetic flux. In the primary side as well as secondary side, the flux linkages. But there is small quantity of flux which we see are lost in the primary side as well as the secondary side. In order to depict this loss in the magnetic flux in the primary and secondary circuit, in terms of the electrical parameters, we are going to use the inductance X1 and inductance X2, which we basically call the reactance X1 and reactance X2. And RC is the core loss component. See, we talk about the core, that is the transformer is composed over the core consisting of primary winding as well as the secondary winding. So in this core, there is small quantity of loss. Which kind of loss? We have seen about hysteresis and eddy current loss. This component RC, that is the core loss component, basically encounters the eddy current losses which is occurring in the core of the transformer. When we talk about the magnetizing component XM, that is the reactance, see, whenever we are going to provide AC source, then some small quantity of or the required value of the rated current start flowing in the primary winding. Now, due to this current, some flux will be generated in this core, which can be given by right hand thumb rule. We know if the fingers denotes the direction of the current, then thumbs denote the direction of the flux. So whenever some current is there, then automatically the flux will be generated inside the core. Now, amount of the energy which is required in order to generate this magnetic flux, that amount of energy in terms of the electrical parameter has been denoted with the help of magnetizing component X1, XM. Now see, which can be seen here. V1 is the amount of the primary voltage which is being fed to the transformer. R1 denotes the resistance of the primary winding. X1 denotes the magnetic flux loss which occur in the primary circuit. Inductor is used in order to depict the magnetic circuit in terms of the electrical parameters. I1 is the primary current, primary winding current. I0 is the no load component of current, and IC is the core loss component. IM is the magnetizing component of current. I2 dash is known as the load component of current referred towards the primary side, because we know whenever the load is going to increase, the value of I2 is going to increase, and simultaneously the value of I2 dash is going to increase, and hence the value of IM is going to increase. This is the figure of the exact equivalent circuit when it is being referred to the primary side. Now here the component resistance and reactances are being denoted by R2 dash and X2 dash. This denotes that these values has been referred to the primary winding side. Now value of R2 dash is equal to A square R2, where A is the turns ratio, which can be written as R2 dash is equal to N1 by N2 square R2, and similarly X2 dash can be found out. And here the value of I2 dash is equal to I2 by A, and also V1 is equal to the required which has been found using the KVL. We can use the KVL loop here and we can find out this equation. One more thing, that I1 is the phasor sum of I0, that is no load component, as well as I2 dash, which we have to keep in our mind. It is not the algebraic sum, rather it is the phasor sum. Similarly, I0 is the phasor sum of IC and IM. That's all for today. If you require some more videos over the electrical engineering, then please do comment and subscribe the channel. Thank you very much.